Hello to all my viewers. This is Dr. Dhaval Maheta, and today we'll understand how to run Probit regression analysis in STATA. Probit regression is a type of a regression model used in statistics to model the binary outcome variables. It is particularly useful when the dependent variable is categorical. Please remember the dependent variable is categorical with two possible outcomes such as yes or no. The another example is success or failure. The term probit stands for the probability unit. Prob stands for the probability, indicating that the model deals with the probability of binary events. Binary events, that is success or failure. Unit refers to the standard normal distributions unit. Now let's understand the link function of the Probit regression. Probit model uses the cumulative distribution function CDF of the standard normal distribution to relate the probability of the binary outcome to the predictors. You can see on the right hand side, the red line represents the logit link function, and the blue, the probit. I'll request all my viewers to kindly refer my video on logistic regression analysis, which is available in the playlist of the STATA. The mathematical form, the probit function is given by the CDF of the standard normal distribution, that is phi z is equal to phi beta 0 plus beta 1 x1 plus beta 2 x2 till beta k xk, where phi denotes the CDF of the standard normal distribution and z is a linear combination of the predictors. To get the probability p, we directly use the CDF, that is p is equal to phi beta 0 plus beta 1 x1 till beta k xk. Let's take an example. Suppose the Probit model for predicting exam pass is z is equal to -1 plus 0.02 study hours plus 0.04 previous grades. To find the probability of passing the exam, what we will do, p is equal to phi, and directly we will take the value of z, so phi z. Now what we will consider? We will consider the standard normal CDF to compute the P. That is the probabilities. The difference between logit regression and probit regression. We start with the link function. Logit regression uses the log odds of the probability. Probit regression uses the cumulative distribution function of the normal distribution. Probability calculations based on the logistic function. These are based on the normal CDF. Distribution used, logistic distribution for error terms. Probit regression, normal distribution for error terms. Curve shape, logistic curve with the heavier tails. Probit regression, normal curve with the lighter tails. Coefficient interpretation, coefficient represents the change in the log odds of the outcome. Here, the coefficient represents a change in z-scores from the normal distribution. Robustness to extreme values, more robust to extreme values due to heavier tails. These are less robust to extreme values due to lighter tails. Computational complexity, generally simpler and faster to compute. These are slightly more complex due to the normal CDF. Applications, commonly used for the binary classification problems. These are also used for the binary classification, especially when the normality assumption is appropriate. Now, let's import the data in STATA. So we'll go in File, Import, Text Data, Browse, click on this Admissions, press Open. This dataset is very easily available on the Kaggle. Press OK. On right hand side, you can see the name of the variables, admit. That is, the student is admitted, yes or no, GRE scores, GPA scores, rank from which the student is applying, that is the undergraduate institutions. You run the command browse to see the entire data frame. Admit, 0 means no, that is a student got the admission or not. So 0 is no, 1 is yes. GRE scores, GPA scores, and the rank of the undergraduate institutions. Now, what is our research question? What is the effect of students' GRE scores, GPA, and the prestige of their undergraduate institution, which is indicated by the rank, on the probability of being admitted to the graduate school? The first null hypothesis is GRE score has a no significant effect on the probability of the admission. Alternative, they are associated. The second null, GPA has no significant effect on the probability of the admission. The alternative, it is associated. The third null is undergraduate institution rank has no significant effect on the probability of admission. Now again, we will go in STATA and run some basic descriptive statistics. So tab, and here we will write rank. So we can see here that 61 students are from rank 1 institute, which they are applying. 151 are from rank 2, 121 from rank 3, and 67 from rank 4. How many got the admission? Admit, tab, admit. So 127 got the admission, 273 did not got the admission. Now how will write the interpretation? These are the same tables. And the red color, this red color text indicates the command. The data reveals that among the 400 students, 15.25% were from the universities with rank 1, while 37.75 were from rank 2. In addition, 30.25 of students belong to rank 3 and 16.75 came from rank 4 universities. If we talk about this table, the data reveals that among the 400 applicants, 68.25 were not admitted, while only 31.75% were admitted. Now we'll run the Probit regression with the command Probit. Admit is our dependent variable. So the labels in it are only two. That is, the outcome is binary, yes or no. GRE, GPA, these are our independent variables, and rank. We will prefix rank with i.rank because we want to convert this into dummies. Let's understand the concept. Rank has got the 4 institutes. That is rank 1, those institutes which are having rank 1, those institutes which are having rank 2, rank 3, and rank 4. So the number of dummies will be one less. So i.rank. So you can see here 2, 3, and 4. Now what about the rank 1 institute? It will be captured with the help of constant. So first of all, let's run this command in STATA. So Probit, admit, GRE, GPA, and i.rank. Enter. And we got the results. You can see here the chi-square value, the p-value, the pseudo r-square, coefficients of the independent variable, the p-value. Now let's do the interpretation of this. The Probit regression model examines the probability of admission to graduate school as a function of GRE and GPA and the undergraduate institution rank. The likelihood ratio chi-square test is statistically significant. That is, the value is 41.56, you can see, and the p-value is less than 0.001, indicating that the model provides a better fit than an empty model. The pseudo r-square value of 0.0831 suggests that the explanatory variables account for approximately 8.3% of the variation in admission probability. So this is a pseudo r-square. It is not equivalent, or it is not equal to the r-square used in the linear regression analysis. Now let's do the interpretation of the coefficient of GRE GRE scores have a positive and a significant effect on the probability of admission. How we can say it is a positive? See this coefficient 0.0013, and we are rounding up. We are rounding it. So 0.0014. P value 0.034, and as it is less than 0.05, it is significant, meaning that a higher GRE scores increase the likelihood of being admitted. What about the GPA? You can see its coefficient, it is very high, 0.477. P value less than 0.05. GPA also shows a positive and significant effect. Beta is 0.478. That is 0.478, and P value 0.015, less than 0.015, less than 0.05, suggesting that the students with the higher GPAs are more likely to gain the admission. Now, what about the rank of the institutes from which the students are applying? You can see rank 2 negative, rank 3 negative, rank 4 negative, and they are all significant. Now, how will write the interpretation? In contrast, the undergraduate institution rank has a negative impact relative to rank 1, the reference category. The reference category is captured with the help of constant. Specifically, attending rank 2, its beta is 0.415, rank 3, 0.812, rank 4 institutes, minus 0.936. Institutions. So what it says, as rank 2, rank 3, and rank 4, your probability of admission decreases drastically. So how will write? Significantly decreases the probability of admission compared to rank 1 institutions. This indicates that the applicants from the less prestigious school face lower chances of admission even after controlling for GRE and GP. Now, we will have to run the command for the robust standard errors. Now, why it is necessary? The robust option adjusts the standard errors to make them valid even when the assumptions about the error terms are violated. In case of logit and probit link function, the basic assumption of the error term is the error terms should be homoscedastic. If it is violated, we cannot rely on the coefficients. So what we do? Let's understand. In a classical maximum likelihood estimations, we assume that the variance of the error terms is correctly specified. If this assumption fails, the usual standard errors can be biased. STATA makes it quite easy. How? By just introducing one more term, comma, robust, in the previous command, we can get both the versions of the coefficients with and without the robust standard errors. So let's run this command. So again, we will go in STATA. We can recall the previous command by pressing page up, comma, and write here robust, enter. So you can see more or less the coefficients are same. So as coefficients are more or less same, the interpretation also remains the same. We can run the same command with the help of graphic user interface also. Go in statistics, binary outcome, Probit regression. Activate from here, admit from here, GRE, GPA, and right here I.rank. Click OK, and we got the output. Now I want to do the correction for the error terms. So again, I will go in statistics, binary outcomes, Probit. Click here, SC, that is a standard error, robust test. Activate this robust. Click OK, and we got the output. See here. This is the corrected values. Now let's proceed further. Now we want to estimate the marginal effects. What are these? Marginal effects are the post-estimation calculations that transform the coefficients from a non-linear probability models like Probit or Logit into a interpretable quantities. They represent the instantaneous rate of change in the predicted probabilities of the outcome occurring given a one unit change in an independent variable while holding all other variables constant. It's very simple. See, we run marginal effects because the raw numbers from the models like Probit and Logit are not directly understandable. So what we want to know, if a student's GPA goes up by 1 point, how much does their chance of getting admitted increases? So for this purpose, we calculate the marginal effects. How we'll do? The command line is margins, comma, dy dx into bracket asterisk at means. We want margins at means. Let's run it. Enter. And we got the value. GRE, mean, GPA mean, rank 1, 2, 3, and 4. Now let's do the interpretation. GRE score impact. Holding all other variables at their mean values, a 1 point increase in a GRE score is associated with 0.048 percentage point increase in the probability of admission. Here is it. We will convert it into the percentage. That's the reason we write 0.048. See, dy by dx is 0.00000.4798. And it is also significant. If we convert it into the percentage, it is 0.048. While this effect is statistically significant, it is quite small in the magnitude. For a more substantial 100-point increase in GRE score, the probability of admission would increase by approximately 4.8 percentage points. Now, what about the GPA impact? A 1 unit increase in the undergraduate GPA is associated with 16.66 percentage. It's a huge effect. 16.66 percentage point increase in the probability of admission. Dy by dx, it is 0.1666, which we have converted into the percentage, and it is also significant, holding all other variables constant. This represents a substantial effect, indicating that the academic performance as measured by GPA has a strong influence on the admission decisions. What about the institutional's ranking effect? 2, 3, and 4. Compared to top-ranked institutions, applicants from lower tier schools face a significantly reduced admission probabilities. We start with second tier. Applicants from second tier institutions have 16.23 percentage point. Where this figure comes from? See, it is here. 0.1622. Percentage point lower probability of admission. Applicants from third tier institutions have a 29.6 percentage lower probability of admission, and they are all significant. Please remember it. Applicants from fourth tier institutions have a 33.09 percentage lower probability of admissions. The negative impact of attending lower ranked institutions is substantial, with applicants from the lowest ranked schools facing about a 1/3 reduction in admission probability compared to their counterparts from a top tier institutions, even if we control the GRE and GPA, the GRE scores and GPA. Now we'll compute the marginal effects at the scores, the GRE scores. That is, we start with 200 and we'll give the increment of 100 and we'll go till 800. See, 200, increment of 100. So 200, 300, and we'll go till 800. Let's run this command. So the command line is margins, comma, at round bracket GRE equal to, again round bracket, 200, 100, 800. Enter. And we got the values. Now let's write the interpretation. This one is for GRE score 200. This 2 GRE score 300 and 7 GRE score 800. You can see as the GRE scores increases, the probabilities of admission is also increasing. We start from 0.16 to 0.415. Now let's write the interpretation. For these predictions, the model assumes an applicant has a GPA of 3.39. So it's from this figure we have written from our previous output, right? 3.39, this one. Okay. So we are holding that as constant. And a proportional chance of being from any rank, that is 15.25% chance of being from a rank 1 institute, 37.75 from rank 2, effective representing an average applicant on all other metrics. Now, considering this GPA and this this GPA and this rank, let's write the interpretation. At a very low GRE score of 200, this one, the predicted probability of admission is low, which is 16.2%. This probability increases steadily with each 100-point increase in the GRE score. At the mean GRE score, that is 588, the probability is approximately 31.9%. The fourth one is 500. So it's approximately 31.9%. This value falls between the predicted 27.4% at 500 and 36.6% at 600, aligning with the marginal effects output. So 588. So at 588, the probabilities are 31.9%. At a very high GRE score of 800, the predicted probability of admission reaches 41.5%. Now let's do the model fit. So before running the model fit, can we run this marginal effects with the help of graphics user interface? Yes, we can do it. Go in statistics, go in post estimation, click here, press plus sign, marginal effects, press marginal means and interaction analysis, add the sample means, press launch, activate the categorical variable here, and categorical rank. There's a rank of the institutes. Press OK, and we got the results. See this. These are the same results which we computed with the help of command. Here is it. Now how about the GRE scores? Again, we'll go in statistics, post estimation, open this, add sample means, launch, make this continuous. So this is continuous, and from here we will select GRE and we will specify that start from 200, increment of 100 and go till 800. Now click OK. And we got the results. These are the same results which we got with the help of the command line. You can check this. Here is it. Now we will compute the model fit. Unlike linear regression, Probit regression does not have a natural R-square, that is a coefficient of determination, because the outcome is categorical and the model is estimated via the maximum likelihood, not the least square. So instead, we use the pseudo R-square measures, which are analogs of R-square. They don't mean proportion of variance explained in the same sense as OLS. Instead, they compare the fitted model's likelihood to that of the null model. What is the command? STAT-IC. That is the information criteria. STAT-IC. We got the output. Now let's do the interpretation. Log likelihood, null model, log likelihood for the model. The fitted model's log likelihood minus 229 is higher, that is a less negative than the null model's log likelihood minus 249, This indicates that including GRA, GPA, and rank improves the model fit compared to using only the intercept. This we can also run with the help of graphic user interface. So for this, we will go in statistics, post estimation, click on this specification, diagnostics, and goodness of fit. In this information criterion, launch, click on IC, click OK, and you can see the result. It will produce the same output. Now let's proceed further. Goodness of fit, that is a Hosmer-Lemaitre test. In Probit regression, the goal is to assess how well the model predicts the observed outcomes. Goodness of fit test evaluate whether the predicted probabilities from the model match the actual data or not. Null hypothesis, the model fits the data well. No difference between the observed and expected. Alternative, the model does not fit well. The command line is STAT. Goodness of fit, group 10 table. Let's run it. Enter. And we got the values. Now let's do the interpretation of this. As a p-value is 0.1260, this one, which is greater than 0.05. That's a 5% level of significance. We fail to reject null. This means that the model shows no significant lack of fit. The predicted probabilities are consistent with the observed data. So what is desirable here? The desirable is that your p-values should be, this p-value should be greater than 0.05. The same output we can also generate with the help of graphic user interface. So we'll go in statistics, post estimation, click here, specification, diagnostics, and goodness of fit, click here, goodness of fit test, and launch, click on this Hosmer-Lemaitre 10 groups, click OK, and just see the result. We got the output. Now let's proceed further. What is the interpretation of these probabilities which are generated with the help of this command? So first let's run this command, predict p hat, comma p, and we will generate list, admit, GRE, GPA, rank, and the probabilities for 1 to 10. So write the command here, predict p hat, comma p, list, admit, GRE, GPA, rank, p hat, the probability of getting admission in 1 by 10, that is for the first 10 students. Enter. We got the output. These are all probabilities. Now let's do the interpretation. Looking at the first 10 cases, for some students with the higher GRE and GPA and better ranked institutions, let's check it. Higher GRE and GPA, okay, and rank in a good institute, right? The probabilities increases. The predicted probability is relatively higher, meaning that the model estimates they are more likely to be admitted. For students with the lower GRE, very low GRE, right, and the rank of the institutions is also lower, the probability is only 0.17. Let's check for the second student. GRE score is good, GPA 3.67, but from the third rank institute, the probability of admission is less, 0.29. Now let's talk about this third one. 800 GRE score, GPA 4, rank 1 institute, see the probability 0.733, it increases. GRE 640, GPA 3.19, but the student is from rank 4 institute, so it is 0.179, the probabilities are low. Now we will generate the classification table. What it is? A classification table, also called a confusion matrix, is a tool used to evaluate how well a classification model such as logistic or Probit predicts the outcome. It compares the predicted categories. So basically it is used in logistic regression and Probit regression. It compares the predicted categories of the dependent variable with the actual observed categories. What is the command line? Stat class or stat classification. Let's run it. And we got the values. These are true values, and these are classified according to the model. Let's do the interpretation. Let's talk about this 30. It's a true positive. In this case, 30 applicants were actually admitted and the model also classified them as admitted. This indicates the model's ability to correctly identify a portion of the admitted students. Let's talk about the true negative. 254. This is also good. True negative. 254 applicants were not admitted and the model successfully classified them as not admitted. This shows that the model performs strongly in identifying students who are not admitted. False positive, 97. So in this data set, 19 applicants were predicted to be admitted, right? But in reality, they were not. This error suggests that the model sometimes overestimates the admission chances. False negatives. Sorry, I was talking about this 19 and this is 97. So here 19 applicants were predicted to be admitted, this plus 1. But in reality, this is negative. They were not admitted. 19 classified as admitted, but they were not admitted. If I talk about 97, this one, they were admitted, but the model classified them as not admitted. A total of 97 admitted applicants were misclassified as not admitted. This is a major limitation of the model as it fails to identify many students who were truly admitted. So the same thing I can also generate with the help of graphic user interface, go in statistics, binary outcomes, post estimation, and here is it, classification statistics. Click on it. Report various summary stats. Click OK, and you will get the same output. Now let's proceed further and generate the ROC curve. The ROC curve is a graphical tool used to evaluate the performance of a regression model like logistic regression and decision tree. It shows how well the model separates two classes, that is positive versus negative, across different classification thresholds. First, let's run the command LROC. And we got the output. Let's do the interpretation. The classification result from the Probit regression model shows that out of 400 applicants, the model correctly classified 71% of cases overall. How did we got this 71%? 30 plus 254 divided by 400. So here is a 71% correctly classified. This means that the model has a moderate level of predictive accuracy. Now, what is the sensitivity? It is 23.62%. This is the number, 23.62%. The model correctly identified about the 24% of the admitted students, true positives. This indicates that the model is weak in detecting students who actually get admitted. Specificity is 93%. The model correctly classified about 93% of the non-admitted students, that is true negative. This shows that the model is highly accurate in predicting students who are not admitted. Positive predictive value, 61.22%. When the model predicts admission, it is correct about 61% of the time. Negative predicted value is 72.36. When the model predicts non-admission, it is correct about 72% of the time. I can generate this ROC curve from statistics, binary outcomes, post estimation, and here is it, ROC curve. Click OK, and we got the results. We can also generate the sensitivity and specificity plot. Go in statistics, binary outcomes, post estimations, and here is it. And click OK, and you will get the result. Now, next thing what we want to do is we want to compare the results of Logit and Probit model. So this is a command, logit admin gre gpa I.rank will save the results with the help of command. This is estimates, then probit, we'll run the command probit, and then estimates, and then we'll compute together. Let's run it. So I've written the command logit admit gre gp I.rank robust estimate store logit model, we will save the model, then probit admin gre gp I.rank robust will save the results, and then we will compute, or rather we will report the results in the table format. So estimates table logit model, which is this, the name given is a logit model, this is a probit model, and then how to report it, enter, and here is it. So this column, the first column is for the logit model and the second column is for the probit model. Both models perform equally well in terms of fit and significance. This you can see from here. Single asterisk, double asterisk, and triple asterisk. Single asterisk means significant at 0.05, double asterisk 0.01, triple asterisk 0.001. The logit model is often considered better in practice because it results odds ratio. These are more straightforward to interpret for applied audiences. However, if your discipline value normality assumptions like econometrics is necessary, probit can be easily justified. You typically need to compute marginal effects to make them more meaningful. So this was all about how to run probit regression analysis in STATA. For more videos on STATA, kindly refer to my playlist. I have also uploaded many videos on data science, machine learning, and artificial intelligence on my YouTube channel named Dhaval Maheta. To watch the full videos, please subscribe to my YouTube channel and check the playlist. Please don't forget to like and share my videos. You can also follow me on different social medias, link given in the description box.